Science from the University of Barcelona, and I am also part of the Institute of Space Science. The topic of my poster is the radio survey of the protostellar population in G14. We studied G14 for its favorable conditions for star formation, as evidenced by a rich population of protostars and young stellar objects, a network of filaments that results in two structures. We observed G14 with the VLA at 2 radio frequencies. We identified the sources of the cloud, and we made an estimation of the spectral indices while searching for counterparts at other wavelengths. We associated sources with non-young stellar objects and other emissions, but the main finding was the differences in the two hubs, likely due to different stellar populations and evolutionary stages, with the northern hub being older and more massive. Thank you for your attention, and now you are ready to deep in more by looking at our poster.
My name is Bjorn Emonts from NOAO. My poster presents the discovery of a cold stream of atomic carbon gas that accretes onto the redshift 4 radio galaxy 4C4117, also known as the N-tail galaxy. This stream deposits molecular gas at a rate that's comparable to the long-lived star formation rate, and therefore it could present the main mechanism for fueling the growth of the N-tail galaxy. And the emission in this stream has a low surface brightness, and it was detected by ALMA in an ultra-compact array configuration. The next generation VLA will allow observations of cold molecular gas across both stream and also halo environments at almost any redshift by targeting the ground transition of CO. But for this, we need an ultra-compact core that's much more densely packed than the current VLA-D configuration. If not, we may be missing out on recovering all the molecular gas in the universe.
Radio provides us with a biased tracer for both star formation and accretion activity and can identify AGN via morphology. However, at the typical arc-second angular resolution scales, most of these AGN remain unresolved. VLB increases the angular resolution of a radio array from arcseconds to milli-arcsecond, corresponding to spatial scales of a few parsecs at the cosmic noon. Therefore, VLB provides us with a powerful tool that zooms into the cause of these galaxies and spatially resolving AGN from star formation. We are employing the wide field VLBI technique to increase the VLBI sample size by increasing the field of view from a few arcseconds to several degrees. These are some of our results from these wide field VLBI surveys, where we are zooming into the centers of these galaxies to reveal obscured AGN merging galaxy system with coevolution of both star formation and AGN, and even making some serendipitous discoveries. This data is already covering the SKA2 parameter space and therefore can be used as a training set sample for the SKA. Thank you.
I'm going to talk about evolution of thermal and non-thermal radio continuum emission on kiloparsec scale, that is prediction for SKA. My name is Masoumeh Nodehi, and I'm from Institute for Research in Fundamental Sciences. We investigate the expected structure of the thermal and non-thermal emission on kiloparsec scale at different redshifts. And we investigate the possible evolution of thermal fraction and synchrotron spectral index as mid-radio frequency. Also, the potential of upcoming SKA1 mid-reference surveys to detect RC emitting structures that are needed to address the role of thermal and non-thermal process in the evolution of galaxies. Surface brightness maps are created at observed frequency of 1 GHz at an angular resolution of 0.6 arcsecond, considering two different scenarios: no galaxy size evolution and with galaxy size evolution. We are going to simulate H1 surface brightness at high redshift with SKA. Thank you.
I'm Isaac Radley, a second-year PhD student from the University of Leeds in the UK, and I'm presenting a multi-wavelength radio survey of the Ophiuchus star-forming region as a precursor for the SKA mid. Ophiuchus is an excellent observational target, as it contains over 300 YSOs and is in very close proximity at 140 parsecs. Our multi-wavelength survey covers the X, K, and Q band, thus allowing us to constrain the spatial distribution of large centimeter-sized dust grains, as well as the transition from millimeter to centimeter sizes. We detect 16 YSOs in the Q band and 19 in the K band above the 5 sigma level, and we find an exceptional resolution of 10 AU in the Q band. We also find that the centimeter emission in general for all our YSOs is incredibly compact, thus indicating a protostellar origin. Please feel free to come see my poster, and if anyone is interested, I'll be available on Slack all week to discuss.
In this poster, I am presenting the detection of a weak non-thermal population from Sun. Using the data of Murchison wide field array and visibility subtraction technique, we were able to image radio burst until the level of milli SFU flux densities. These are quite relevant in context of coronal heating problem in Sun. I'm also presenting some mock observations from SKA low and SKA mid and their precursor telescopes. The SKA low and SKA mid solar observations will be unprecedented in their dynamic range and fidelity. So please have a look at this poster. Thank you. Array and visibility subtraction technique, we were able to image radio burst until flux densities. These are quite relevant in context of coronal heating problem in Sun.
Hi, everyone. I'm George Shield from the Australia Telescope National Facility, which is operated by CSIRO here in Australia. My poster is about two main ways in which ATNF is evolving to better complement SKA capabilities in the next decade. First, we are planning to upgrade the ASCAP radio telescope with the aim of increasing its survey speed. This will provide better complementarity at SK mid with extra value for all sky surveys and follow-up of transient and variable sources. Second, we're improving our VLBI capabilities. We're doing this to support long baseline work with SK mid, and we are also exploring an expansion to low frequencies to enable VLBI with SK low. If you have any questions, please feel free to contact me. And if you're at the meeting in person, please speak with Douglas Bach. Thank you.
Hello, everyone. My name is Lina Preston, and I work at the University of Manchester as part of the SKA PSS team. We are developing pulsar search backends for this SKA telescopes, and we've put together a poster describing the different observing modes and data processing flows that are currently being developed for the SKA telescopes. So please have a look at our poster if you're interested in knowing more about the software and hardware development that we're doing, and the processing pipelines that will be used to discover over 10,000 new pulsars with SKA telescopes. Unfortunately, can't be there with you in person, but if you have any questions, I'm available on Slack or email, so please do reach out. Thank you.
Hello everyone, I'm Ankita Bera from Presidency University, and this work I did during my pre-doc program at Flatiron Institute. Probably everyone is aware of the AGES detection of the global 21 centimeter signal, and it has been shown that the AGES results are consistent with the extrapolated UV luminosity density. And we consider this as our observational constraint during cosmic dawn, and along with that, we considered these reionization and post-reionization observables. And then we explored the conditions by which the observations are consistent. And we did this by coupling this physically motivated source model, which is derived from the radiative transfer simulations, to MCMC sampler. And we find that high contribution from low mass halos along with high photon escape fractions are required to simultaneously reproduce the high redshift and low redshift constraints. Then comparing with the Thiessen reionization simulations, we find consistent results. Now, depending on more observations during cosmic dawn that we are hoping to get from SKA, we'll be able to constrain our early or late reionization models. So if you have any questions, please feel free to email or Slack me. Thank you.
Hi, I'm Mechiel Bezuidenhout. I'm a postdoc at Northwest University in South Africa. I'm also a member of the MEERTRAP collaboration, which is carrying out a real-time search for radio transients with MeerKAT. We have a custom backend at the telescope that operates commensally with other MeerKAT users and that is continuously performing a single pulse search. In our 3.5 years of operating, we have amassed around 25,000 hours on Sky, and we have discovered 121 new sources, of which 82 are galactic and 39 extragalactic. That works out to around 3 new discoveries every month. Among our most exciting discoveries include the slowest spinning pulsar ever discovered with a period of 76 seconds, and also the pulsar with the strongest magnetic field, 10 to the power 16 Gauss. Those are just two of our exciting discoveries. If you're interested in learning more, check out my poster or send me an email. Thanks.
Hi everyone, I'm Emma Carli, a final year PhD at the University of Manchester in the UK, attending online. Extragalactic pulsars are very rare, as they form only 1% of known pulsars. Thanks to the sensitivity and targeting capabilities of the Meerkat telescope, we have doubled the radio pulsar population in the small Magellanic Cloud galaxy. Half of our discoveries there are young and glitching. We are now searching the large Magellanic Cloud, and we have already increased the population there by a third. You can find out more on our collaborations website, trapum.org, or in our first paper, Carli et al. 2022, or you can check out my poster and email me your questions. Thank you.
Hi everyone, I'm Stefan. I'm a postdoc at CSIRO working on the Rapid ASCAP Continuum Survey, which, as the name suggests, is meant to be a fairly rapid survey being performed by the Australian SKA Pathfinder. The main data products are Stokes INV continuum images in 3 bands between about 900 and 1600 megahertz. These surveys go up to a declination of about 49 degrees with resolutions of order about 10 to 15 arcseconds. The sensitivity across the 3 bands is generally pretty consistent at around about 200 microjansky per beam, and the first of the surveys, RAX Low, at about 900 MHz, has been completed and released and is currently available on the CSIRO ASCAP Science Data Archive. The second of these surveys, RAX Mid, at about 1367 MHz, features a number of improvements which have helped the overall data quality and will be available on CASDA shortly as well. Lastly, we have SPICE-RAX, which is the linear polarization component looking at rotation measures across the sky. The initial SPICE-RAX release is in the low band and covers a region of sky of about 1300 square degrees, and this is close to release as well. Thanks.
I, Marcin Glowacki, will convey. I'm from Curtin, Australia. Good day. With Craft, we want solutions for high time resolutions of profiles of an FRB survey. With ASCAP, we use a pipeline. Called Celebi, it does the job fine. We localize each one, then beamform for fun, and obtain high time res data to mine. With dynamic spectra, such as these, we fit for scintillation as we please. In some cases, we constrain, scattering within the plane, and find each previous study agrees. And this is just the start, you see, as Craft will get hundreds a year, we agree. If you'd like to see more, see our poster, I implore, to gaze at data for each Craft FRB.
Good day to everyone. If you look at this spectrum taken at the site of the Effelsberg radio telescope, you will notice that wide ranges of it are occupied by anthropogenic transmissions. Only a few radio astronomy bands in green are actually protected. This will become a huge problem in the future. Radio communication industry wants fast internet to become available to everyone, everywhere on the globe, with more and more spectrum allocated to mobile communications. So, spectrum management, the protection of radio astronomy, is an important investment. We want to invite you to participate in radio astronomy protection. Raise awareness in public talks and outreach articles. Make politics aware of the importance of research. Get informed about RFI when planning your research. Report RFI to your observatory. Work with the industry to find solutions to protect observatories. Please have a look at the poster and get into contact with us.
Hello. My poster is about dipole asymmetries seen in 2 large radio surveys, VLASS and RACS, and the discordance of these dipole asymmetries with the CMBR, cosmic microwave background, and thus problem with the cosmological principle. My name is Ashok Singal. I belong to Physical Research Laboratory, Ahmedabad. Now, these 2 radio surveys show dipoles which are much larger than the CMBR dipole, about 4 to 7 times larger, which is not in accordance with the cosmical principle. That is my poster about. Thank you.
We present a compendium of polarization observations in low-mass evolved stars, pointing out the importance of these studies to measure the strength and geometry of the magnetic field associated with them, all the way from the AGB to the PN phase. Thus, continuum emission has already been observed at frequencies higher or equal than 178 GHz. We expect thus continuum at the smaller frequencies might be detected and mapped with the powerful next generation BLA, and even measure the polarization in different phases of evolved stars within an unexploited frequency range. Regarding polarization of molecular maser and thermal lines, most of them have already been detected at frequencies within the bands of the next generation BLA or higher. We consider that new molecular transitions or new molecules can be discovered with the very high sensitive next generation BLA in the circumstellar envelopes.
Hi everyone, I'm Takafumi Tsukui from Australian National University, presenting this poster on error analysis under the spatially correlated noise. As you know, noise in the interferometric image has a spatial correlation, looking very different from the wide uncorrelated noise, even with the same root mean square level. We can measure the noise correlation pattern by taking odd correlation of the noise map, which shows a very similar pattern as the Darry beam with the central main lobe and long-range side lobe. The Darry beam is imprinted into noise as a correlation pattern, even in the clean images. The noise odd correlation function fully characterizes the noise properly, so we propose to use this odd correlation function to estimate the statistical uncertainty of the various measurements, such as spatially integrated flux over a certain region of the sky, and parameter estimations with the model fitting under this correlated noise. This computer code is publicly available for everyone to use it easily. Please visit our poster for more details.
Hello, my name is Shane O'Sullivan, and I'm working at the Complutense University in Madrid. My poster presents the LOFAR Faraday rotation measure grid, which has enabled us to illuminate dark phases of magnetized gas, such as filaments of the cosmic web and the circumgalactic medium. We find that cosmic web filaments are magnetized with a strength of order 10 nanogauss for the typical filament overdensity in the local universe. With this data, we can also rule out certain models for the origin of cosmic magnetism, such as a primordial uniform magnetic field with a field strength greater than 0.1 nanogauss. The ORM grid catalog is publicly available, so please check out the link on the poster.
Hi, my name is Dr. Catherine Hale. I'm currently a Leverhulme Trust Early Career Research Fellow at the University of Edinburgh, and I'm here to talk quickly about our poster looking at cosmological studies with the LOFAR 2-meter sky survey, and this has been created by members of the LOFAR survey's cosmology team. In our poster, we'll present the data that we've used, the LOTS 2-meter sky survey, as well as some of the cosmological analysis we've done, so looking at the one-point statistics, the radio dipole, angular clustering, cross-correlation, and with both CMB and EBOS, and finally talk about what this means for the future with the SKAO and NGVLA. So one of the things that's become critical in this is understanding the systematics in the data, and by jointly using these two telescopes, we can help try and understand some of these and remove them so that we can do cosmological analysis. So please take a look at our poster, and if you have any questions, my email's at the top. Thank you very much.
Hello. My name's Andrew Hopkins. I'm Professor of Astronomy at Macquarie University, and I'm the project leader for EMU, the evolutionary map of the universe. EMU is the touchstone radio continuum survey of the Southern Hemisphere. It will cover 2 pi steradians of the sky by 2027, and we expect to extend it to cover up to 3 pi steradians subsequently. With 20 microjansky RMS noise sensitivity, we anticipate detecting 40 million radio sources, as well as delivering unprecedented observations of the Milky Way and nearby galaxies. The science goals of EMU are very broad, ranging from star formation and evolution in the Milky Way and nearby galaxies, to galaxy evolution and the link between galaxies and supermassive black holes over the history of the universe, as well as cosmology and discovering the unexpected. EMU is an international collaboration of over 400 researchers, and it's an open collaboration, by which we mean that anyone is welcome to join as long as you're willing to abide by the team policies. If you'd like to know more, please get in touch. The EMU management team can be contacted at emu_mt@mq.edu.au. Thank you.
Hi, everyone. My name is Assaf Horesh, and I'm a researcher at the Hebrew University of Jerusalem in Israel. Today, I want to briefly present to you our recent discovery in the field of tidal disruption events, or TDEs in short. TDEs are events in which stars are being torn apart by supermassive black holes. As a result, transient emission ensues. Prompt radio emission, for example, has only been detected in a rather small number of events, revealing either relativistic jets or subrelativistic outflows, launched briefly after stellar disruption. We have discovered several events with no prompt radio emission, where the radio emission turns on at late times, months and years later. These delayed radio flares can be a result of a newly launched outflow at late times, possibly as a result of a transition in the black hole accretion state, or in other cases, originating from off-axis jets. We also found evidence for a delayed radio flare occurring after a delayed X-ray flare, with features similar to X-ray binary flares. We, and now also others, continue to find a growing number of such events. There are two key observing strategies leading to this discovery. One, exploring various timescales from days to years, even in light of null detection. Two, carrying out high cadence observations. Thus, in addition to the science, a key conclusion is that we need to explore the option of having small, dedicated time-domain radio facilities alongside the big facilities such as SKA and NGVLA. Thank you for listening.
Hello, everyone. I'll talk about how we can understand the evolution of nuclear galaxies in chemical evolution models. We have developed chemical evolution models for the entire nuclear galaxy. These models mainly take care of evolution of the galaxy from a chemical point of view. So we take different generations of stars and then they contribute to the present day evolution of galaxy. We have followed multi-zone galaxy chemical evolution concepts. So from inner 2 kiloparsec of the galaxy, we divided it into 2 kiloparsec. These are the different galactic observables that we've gained for all the regions from star formation rate to supernova. I want to talk about surface gas mass density. This is the distribution for different regions from beginning at 2 kiloparsec to 18 kiloparsec. And here I have compared the present day observations with the predicted trends from our nuclear galaxy. So if you have any questions, please write back to me. And thank you.
Increasing strength, bandwidth, frequency range, and occurrence of radio frequency interference is a significant threat to radio astronomy because saturated signals due to strong RFI lead to spectral confusion. To avoid this, sample widths must be increased to increase the signal dynamic range, resulting in more computational resources and longer design times. Key FPGA and GPU vendors are now facilitating hardened resources to perform arithmetic operations with low precision floating point formats such as float 16, bfloat 16, and TensorFloat 32. Floating point formats can extend the dynamic range of signals at the expense of precision. Here we studied the signal-to-noise ratio achievable with fast Fourier transform operations implemented with low-precision floating point formats and the resource consumption for FFT sizes used in the correlated beamformer of the square kilometer array mid-telescope. According to the results, although float 16 may marginally be able to achieve the desired SNR, the currently used fixed 19 format seems to be the best option overall.
Hi everyone, I'm Sambatriniaina Rajohnson, a final year PhD student at the University of Cape Town, and today I'm going to present shortly some new eyes on the zone of avoidance. The paucity of data in the galactic plane due to dust obscuration prevents us from proper understanding of the overall bulk flow of the universe, over which the direction and especially the volumes where it arises were seen to be controversial. Later results suggest a considerable mass axis found exactly at the location in redshift space where the Villa-Siberian cluster was recently discovered, but is still poorly mapped. So to probe its inner part, only a transsystematic survey does prevail. With over 800 fields observed at SK precursor Meerkat, we conducted 2 contiguous H1 blind surveys located in the most difficult part of the sky, aiming to map the inner part of the supercluster and study its effect on the cosmic full fields. So if you want to know the lessons learned from the hidden structures of the Gyula supercluster, or how did you manage such large surveys, please have a look at my poster. Thank you.
Hi, I'm Shintaro Yoshiura, a postdoc at National Astronomical Observatory of Japan. The title of this poster is EOR Activity of SK Japan SWG-EWG. In this poster, I would like to introduce about EOR activity of the SK Japan Consortium. We recently published a review paper regarding the 21 cm signal at the epoch of reionization at cosmic dawn. This paper describes basics of 21 cm signal and simulation of POP3 stars, and we summarize the current 21 cm line observations. In this poster, I also mention about the sciences we have focused on, such as cross-correlation between 21 cm signal and high-redshift galaxies, and the data analysis of SK1 precursors such as Masoumeh wide field array. Please find the poster, and the review paper is available by scanning the QR code on poster. Thank you.
Hello, my name is Mark Lacy, and I'm here to tell you about NOAO Science-Ready data products and the VLA Sky Survey. NOAO has started a Science-Ready data products program to create processing pipelines and quality assurance procedures for data products from NOAO telescopes. The VLA Sky Survey, which is a new all-sky 2.5 arcsecond resolution multi-epoch survey, is part of this program. So on this slide on the left, you can see an example of a user-driven ALMA image, which runs the ALMA pipeline to your preferred binning and resolution. Second on the left is a field galaxy in the VLA imaging pipeline run. The VLA imaging pipeline is now run on all data sets at C-band and above. And finally, VLAS has imaged the entire sky visible to the VLA twice at this point at 2.5 arcsecond resolution. Thank you.
Hi everyone, my name is Aika Oki from the University of Tokyo. This is the title of my poster. In my poster, I introduced the result of VLA observations at 6.7 GHz. We observed the central AGN core of the brightest cluster galaxy in the Phoenix Galaxy cluster, and the results are shown in the central figure. The horizontal axis shows baseline length and spatial scales. The vertical axis shows flux density. Surprisingly, AGN core was fainter than expected and could not be detected by VLA observations. The right figure shows time versus spatial scales and flux density. We used it to describe the source size and time variability of the AGN core and its surrounding environment. That's all. Thank you for listening.
Hello, I'm Emma, and I'm a postdoc at JBCA at the University of Manchester. As a part of POSSUM, the Polarization Sky Survey of the universe's magnetism, I've been looking at the Faraday rotation of well-resolved radio galaxy lobes. Here, I'm presenting a snapshot of my work on the first POSSUM pilot survey, which I summarize on the bottom left of my slide. Above that, top left, is a whirlwind tour of the background of this project and the big questions. Ultimately, we aim to disentangle the effects of many potential contributions to the observed Faraday rotation. Do we just see the effects of a foreground screen, or is there something happening which is intrinsic to the radio galaxy lobes? On the right, I've shown an example of just one of the sources we've been looking at within the POSSUM Pilot 1 field. To find out more, please have a look at my poster. There are some more POSSUM goodies on Jennifer West's poster, and please keep an eye out for the POSSUM papers that we have in prep, both for this work and the main survey overview. Thanks for listening. Hope you're enjoying the conference.
Hello, my name is Philippa Hartley. I'm an observatory scientist at the SKO headquarters in the UK. Here in our science team, we've been preparing a series of science data challenges to help prepare you, our science community, for future data from the SKO telescopes. We're now on to our third science data challenge, which is based on the epoch of reionization. And you can still get involved in this challenge if you're interested. Just have a look at the links at the bottom of the poster. We're also looking forward to a magnetism science data challenge and more besides. So please stay tuned and have a look at my poster for more details on the SKO Science Data Challenges. Thank you.
Hello everyone, in my poster I'm presenting the panchromatic SED modeling of infrared bright galaxies, specifically luminous infrared galaxies. So first we did radio-only SED modeling, and we see that the shape of the radio SED is not typical power law but rather show complex shapes, and also the spectral index for our sample of galaxies varies from -0.45 to -1.75. We also did FUV to infrared and radio SED modeling using Singal, from which we estimated the infrared star formation rate at 10 megayears ago and 100 megayears ago. This we compared with the radio star formation rate at 1.4 gigahertz. Our radio-only SED modeling enabled us to decompose the total radio continuum into the thermal and the non-thermal emission component, from which we estimated the respective star formation rate. And we see that there is a close correspondence of the total and the non-thermal star formation rate with the infrared star formation rate at 10 megayears ago, which is a more recent star formation. Hence, we say that 1.4 gigahertz SFR estimate is a good indicator of recent star formation.
Hi everyone, I'm Jasper Wall from of UBC, and I don't have a poster, but I do have a book I'd like to draw to your attention. It's called Radio Astronomy in Canada, and it tells the tale of the lonely figure of Arthur Covington plodding in the snow to set up his 10 gigahertz solar monitoring system, right on through to the ups and downs of Canadian astronomy to our current position of being deeply involved in billion-dollar international projects, ALMA, SKA, etc. I have many copies of this. It's proof that this book is actually happening, because this is the proof of the cover from Springer. It's in production phase at the moment, and I hope it will be out before the end of 2023. I want to thank many colleagues who helped with this massive number of interviews, large number of contributions sent in, and pulling that all together was the task that I and Elizabeth Griffin set ourselves, as you'll see from the blurb on the back of the cover. So pick up one of these if you wish, if you're interested. Springer will have probably be issuing discount forms. I don't know how many I'll get, but first come, first served. So send me an email and I will do my best. Okay, thank you very much.
Great, so I think we should thank all the speakers today again and enjoy the afternoon.